Hello and welcome to our tutorial on how to connect the LiDAR with an articulation platform and various components in order to 3D scan the environment. My name is Narek Garakanyan, my partner Biayna and I are going to walk you through the setup. We are using a 3-channel DC power supply in order to power our devices. We are going to use banana cables in order to connect the devices. Channel 1 is going to be the LiDAR. Channel 2 is going to be the servo, and channel 3 is going to be a cooling fan which is being used to keep the temperature of the LiDAR in a normal range. Next, we need to set the voltage and current for each channel. The LiDAR is going to use 12 volts, so we're gonna set the voltage to 12 volts and the current to 1 amp. For the servo, we need to set the voltage to 12 volts and the current to 1.4 amps. And for the cooling fan, the voltage is going to be 5 volts and the current is going to be 0.12 amps. Since these devices are very sensitive, we recommend to check the entire setup to make sure that everything is set up correctly. Also note not to turn on the output of the power supply until everything is connected, which is going to be our next step. Using a USB cable, we are going to connect the LiDAR to our computer, in this case a NUC. Next, using a 3-pin cable, we are going to connect the servo to its power supply. In this case, we are using the SMPS2 dynamic cell adapter. Using another 3-pin cable, we are going to connect our power supply to the Robotics USB dynamic cell adapter, which allows us to communicate with the servo. Once everything is wired correctly, we are going to hook up the adapter to the computer. Note the red LED indicating that it's turned on. Next, we are going to connect our SMPS2 dynamic cell adapter to the channel 2 of our power supply, which we set earlier. By the way, this is the cooling fan that I mentioned earlier. Now that everything is connected and wired correctly, we are going to turn on the output of the power supply. The red LED on the power adapter is going to indicate that it's receiving power. Now that everything is powered on, we are going to start our software. We are using Ubuntu 14.04 as an operating system in a virtual environment. Ubuntu is a popular Linux distribution. Make sure that ROS, which stands for Robot Operating System, is installed on Ubuntu. For more information on ROS and the particular version that we used in this video, please see the documentation in the description below. In order to run our program, we need to open 3 different instances of terminal. All the command lines that are being used in this video can be found in the description. In the first terminal, we are going to run ROScore. In the second terminal, we are going to run the Hokuyo node. If you're in a virtual environment, you first need to run an extra command. And finally, in the third terminal, we are going to run our main program. Our main program is written in Python, and a link to the download can be found in the description below. The main program is going to ask the user for input. Make sure to put your answer into double quotation marks. A valid email address should be entered since the application is going to email the final image. The main program is a fully automated application. It scans, creates a 3D point cloud of the scanned object, plots the points, creates 3 different angle views of the scanned object, it combines them into one image, and sends them via email.